Thank you very much. I'm very pleased to be able to share with you all the work I've been doing on Carnac. I've taken on some of Professor Thom's study. Professor Thom, who most of you must know about, did quite a lot of surveys in Carnac, but he was 76 when he went there for the first time, and so it was pretty difficult for him to go a lot further. So we'll be seeing quite a lot of Professor Thom's plans, which are fantastic plans, and without his work, I would never have been able to do the study I've been doing. So this is an aerial view of the alignments. I'm going to start, first of all, with a few images. This is the Menec West alignments in Carnac. The Carnac alignments, today there are more than still standing over 3,000 stones in alignments. This is a sunrise along those alignments, one full moon after spring equinox on the 21st of April. Now I'm going to try and talk in 1 hour on these 9 subjects which are coming up here, so I'm going to be going quite fast. We'll be talking about, first of all, a general view of the alignments, a few ideas about what is sacred space, and then details of different sections of the alignments, Le Menec West, Le Menec East, the Tumulus Saint-Michel, and the relationship between Le Menec and the next series, which is Kermario, the Kermario West and Summer Solstice, and then I'll be talking about Newgrange, Knowth and Douth, and Long Meg and Castlerig, and showing how the geometry which has been used in Carnac can also be found in these sites. So let's get started. First of all, I'll position Carnac. There you can see the south of England and Brittany. The Carnac alignments are situated in a very densely populated megalithic area in southern Brittany. Here it is in a zoom, and the Carnac alignments are here. So there are officially three series of alignments, which are called Le Menec, west and east, Kermario, which are here, Kermario here, and Kerliscan, Le Petit Menec here. That's 4 kilometers approximately, 4 kilometers long. Firstly, the Le Menec alignments. I'll be going into quite some detail on the organization of these alignments. Then the Kermario alignments. I'll be showing that there are 2 major axes which were used to build these alignments. And the Kermario alignments we'll see are aligned towards sunrise. If you look in one direction, it's sunrise at summer solstice. So if anybody's coming to Brittany this summer, we'll be going to see that sunrise along those alignments. Or if you look in the other direction, then you get the sunset on winter solstice, which is what you see here. So here's another view of the Kermario alignments. They're very big stones. There's a dolmen at the beginning, which we'll be looking at. You can see how big. I was saying my wife is quite small, so she's good to make the stones look very big. But they are very big stones. Some of the stones in Brittany, the largest is a massive standing stone, 350 tons. But in the alignments, there are stones weighing 77 tons, for example. The third part of the alignments is called Kerliscan Le Petit Menec. It's got 2 names because it's been divided into 2 by a road. So the left-hand part here is called Kerliscan. The right-hand part, which is on a curve, is called Le Petit Menec. These alignments are on an east-west angle. And they have a perpendicular line at the beginning, which is north-south, but I won't have time today to go into detail on this site, unfortunately. Now, I'd like just to say 1 or 2 words about the notions of sacred space. The idea that I want to say is, firstly, there is no possible existence of an external sacred space if there is no idea of an inner sacred space. An external sacred space must necessarily be a representation of something which exists inside the human soul. Otherwise, there would be no reason to do it. There'd be no reason to build it if it wasn't a representation of something which had some inner reality. And that's why man is sometimes shown as here, as a geometrical being. Here we can see his body is a square and his head is one of the shapes of Professor Thom's eggs, what he called the flattened circle. Here's another one. See how the square, which is the body, is divided into 9 parts with a central square, and the head again is oval. So if we look at the idea of the basic sacred shapes, of course, there's the circle, which is linked to the heavens. Everything in the heavens is circular. Things all move in circles, and they look circular. And circles can't be orientated. Whereas if we come onto the earth, then the earthly representation of the circle is the square. And that introduces the right angle, the 4 cardinal directions. And that is something which is very linked to our society. I mean, if you look around you, count the number of right angles. They started at one particular point somewhere. Someone introduced the first right angle. Because before that, when men were nomads, or when humans were nomads, they circulated. They lived in round houses, like Mongols live in yurts and Eskimos live in igloos. They live in round shapes. Pygmies live in round shapes. And when we started putting squares on things, then we stopped moving. And that's a very important point. In the square here, I've put the Kerliscon stone enclosure. At the beginning of the Kerliscon alignments, there is a square stone enclosure. After the square, we then have the double square. So if the square is the representation of God on earth, if you could say it like that, or the heavens on earth, the double square is the temple. Now, the monument I'm showing here is a tumulus Saint-Michel. I'll be coming back to that, but that is a double square with rounded sides. It's twice as long as it is wide, twice as long as wide. Now, after the double square, we get the triple square, which is the square plus the double square. You see here I've put an angle. I'll be using this fact. When we do a diagonal here, this gives us an angle. And it also gives us a root number on the diagonal. Now, root numbers are what are called irrational numbers, and we don't like those. Nobody likes square roots, because you can't sort of, take them in. And what I'll be showing is how, in prehistoric times, the Carnac builders actually got round the problem of square roots and made them acceptable. So this triple square is the basis of the Carnac, the first part, the Menec alignments. What you have to realize is that all the pictures I'll be showing you are perfectly orientated on the north-south axis. You have north-south here. So this is a north-south triple square, and the angle of the alignments goes along the diagonal of that triple square, and I'll be going into detail on that. A very important point is the fact that you can then make the next shape, which is a 3-4-5 triangle, by putting 2 triple squares, a horizontal one and a vertical one end to end, a horizontal triple square, vertical triple square. That gives you the 3-4-5 triangle. And by doing that, you double the angle. This is a very little known fact. The angle here is 18.435, and you double it here. The 345 has a 36.87. It's not an approximate double, it's a perfect double. This is rounded, but you could go to 100 decimal places, and it's a perfect double of the angle. And we'll see that this was a key to the building of the Carnac alignments. So before we go to Carnac, just a few examples of sacred architecture which are very well known. We'll start with the pyramids and the King's Chamber. The King's Chamber, as you can see, is a perfect geometrical shape, and it's been set in the largest building on the earth, which means it hasn't moved. And if we see how that's done, I think Mattila Gica pointed this out first. The base of the King's Chamber is a double square, And the height of the king's chamber is a double square along the diagonal. So if you take the diagonal of the double square, the height of it is half the diagonal length. And then what he realized was that if you draw in the volume from one corner to the other corner and down the side, that in fact gives you a 3-4-5 triangle. So in this volume, the double square is used twice to create a 3-4-5 triangle. Now that's an incredible fact. That's not, a sort of approximate imaginary thing. And this is 2,000 years before Pythagoras. Solomon's temple in the Bible, the dimensions were given by God for Solomon's temple. So the first is the Holy of Holies, which was a square, 20 by 20 cubits. And then the temple was 40 cubits by 20 cubits, making the whole thing, so the temple's the double square, the Holy of Holies is a square, and the whole thing is the triple square. It was 30 cubits high, which means that you've got a 3-4-5 triangle on the height, 30 cubits, 40 by 50. That is not mentioned in the Bible, the 3-4-5 triangle. Now let's get to Carnac. That's just a sort of introduction about, you're going to see. Carnac, then, as far as dates are concerned, we're talking about something like 4,500 BC. So something like 2,000 years before Stonehenge, right? It's something very important to take in, that this was going on a lot earlier than what was going on in the British Isles. This is Professor Thom's plan of the Menec West egg, and we'll see how he's based his plan. He says that this egg was traced using 2 3-4-5 triangles placed back to back, and he gave these dimensions in megalithic rods. The megalithic rod is 2.5 megalithic yards, or 2.073 meters. And this triangle, he gave us 15, 20, and 25 megalithic rods, and I'll show you why it's that size in a while. And these 2 back-to-back triangles are then used to trace the egg, as I'll show you now. If you take the central point where the 2 triangles join and draw a circle, you get the rounded part of the egg. If you then go to this corner here and draw a circle from that axis, you get that side. The same thing on the other side. And then the final bit is drawn from this point. That's how the egg is drawn, around the 3-4-5 triangle. Now, when I looked at Professor Thom's plans in detail, because having been living in these megaliths for so many years, there've been a certain number of things I've noticed which seem strange. And for many years I've been trying to understand why there are these strange things. And the first thing I noticed when I looked at his plans is if you add the total of the first 4 rows in megalithic yards here, 8 plus 8 plus 10 plus 12 gives you 38. If you then add the total of the next 3 rows, you also get 38. And if you then draw the diagonal, that gives you the exact beginning of the angle of the alignments. So the alignments seem to have been clearly built around a double square, and this strange angle at their beginning, which is not perpendicular, is in fact the angle of the diagonal of a double square. Now if you add the next 3 rows together, 14 plus 14 plus 10, you get 38 again. And if you draw the diagonal of that, that's a triple square. Now, Professor Thom thought there were 12 rows, but there aren't 12 rows. There were only 11 rows. I have reports from the 19th century by Félix Gaillard, who clearly states there were 11 rows of stones. And you can see that the 12th row shown by Professor Thom does not have stones on it, which makes it a rather hypothetical. So this part of the Carnac alignments, the Menec West, there are 11 rows and 10 spaces. And yes, if you draw the line then from the topmost corner down to the corner of this triple square, which is on the basis of the last line, you discover that in fact that line is perfectly north-south orientated. So the triple square has given its orientation to the alignments themselves. And then just to point out, if you then add another 38 megalithic yard square, you get down to the bottom of the egg. Now, let's put this north-south. So now we're looking at it as it actually is orientated towards the cardinal directions. It's north-south orientation. And I'd like to point out here some particular stones. Look at these three. These three stones are strangely aligned. They are not aligned along the lines. The lines are here, and you've got three stones here. And they're in fact east-west orientated stones. And there's another special stone. There they are. And there's another special stone here as well. This one. This is what I call the table stone. It's a big, flat, round stone which is on the ground, which was never erected. And there is one of these at the beginning of each series of alignments. Now, that's it. That's the table stone. And here you can see them from the air. There are the three stones here, which you can clearly see are not in the same alignment. And that's the table stone with those people on it. Now, if we come to this plan now, and we're going to turn this shape around the table stone, okay? You see that it perfectly positions those three stones on an east-west basis. So that 38 megalithic yard double square can also be positioned perfectly north-south, as shown by those three squares. And you can divide that into two parts, which gives it 4 squares for 19 megalithic yards, which will position rows 3 and 6. Now, I'll now draw your attention to some more stones. Today there are 3 stones here. Initially there were 2. Someone's added a third stone. I'll show you the photos. But these are important because these are the most northerly stones. I do not think, in fact, I think that the cromlech, or the egg, has always stopped here because there's a blocking stone. That's a blocking stone. It's in a different direction. And I don't think this part was ever built. I think that was open. So these stones are the most northerly part of this alignment, of this egg here. Now, they position a very important point because, as we shall see, first of all, here they are, the 2 stones. They actually show 2 triple squares. When you look at them, the angle of the top of that one is exactly the angle of a triple square. And those are 2 identical triple squares which give the width and go from that corner to this corner. So that's very interesting. And this is a photo from 1892, and there you can see there were only two stones there. So the third stone was then added on. There they are. So if we go, and you'll see that the most southerly stone is further south than row 9. The first stone positions row 9, and the second stone is slightly further south, and we'll see why. If I add another 19 megalithic yard square, I come to row 9, and then if I add another 2 towards the east, that enables me to position row 9 exactly on the diagonal of the triple square. See? So we see here how these alignments could be constructed using the triple squares. So we have 95 megalithic yards down there. Now, just a little geometry. What I'd just like to say here is I'll be saying some things about geometry which, in fact, I don't think people know about. And what I'd like to say is that these geometrical ideas are not ideas that I knew about and then adapted to the megalithic sites. They're in fact ideas that I've discovered from studying the megalithic sites. So I've learnt this from the megalithic sites. Right? Now, if you take a triple square, and along the diagonal of that triple square, you add what I call a septuple square, 7 squares, and you draw the diagonal of that, which has an angle of 1813. If you add the 2 together, that gives you 26.565, which is the exact angle of the diagonal of a double square. So by putting one shape along the diagonal of another shape, you can create a third shape, and these are in identical proportions. These are exact relationships, which means that you get rid of square roots, basically. And I'll show you how this was done in Carnac. So here we are back at the Menec egg. And if I take the lower stone here, the further south stone, which is the one which is in fact perfectly, this one is perfectly south point with respect to point A here, which is the sort of central geometrical point for the whole thing. Now I can put a triple square down there from that point to point A with 31 megalithic yards side. That will give me a diagonal of 98.03 megalithic yards, which is fairly close to a round number. But 98.3 98 happens to be 7 times 14. So if I put 14, as we can see here, it was the distance between these alignments. So it was used quite clearly in the building. And if we place down here these 7 14-meter squares, the left-hand side, as you can see, exactly positions Professor Thom's 3, 4, 5 triangles. I've pressed the button a bit fast here. If I take the corner of that septuple square, the southern part here, and this central table stone, I can then draw a triple square here which links the center of Thom's egg through the table stone and through this corner here on a triple square. Now this diagonal of the triple square is perfectly east-west because the triple square is orientated along the alignments, and the other diagonal of this triple square positions exactly the end. It goes through the center and positions the end of this arc here, and it's the angle of a 3, 4, 5 triangle, so it points to summer solstice sunrise. Just to see the geometry of that, if you take a triple square which is inclined and you draw the two diagonals, you get the two twice that degree, which is the 3, 4, 5 triangle angle, twice that. So this is very interesting and unknown geometry taking place here. And if I take this same triple square and I put it on the end, I see, in fact, how it exactly goes from row 8 to row 1. If I add all those lines up, that gives me 76 megalithic yards. So that triple square has a size of 76 megalithic yards, which, if you may remember, was the size of 4 of the red squares. So we see how this geometry and this metrology is divided first into 3, or first into 4 and then into 3, as we saw with the first 4 rows being equal to the distance of the next 3 rows. And this relationship between 3 and 4 is a very important subdivision, which we'll be seeing in a bit. So, while we're still on the egg here, if I then draw exactly the same 5 squares here, we'll see that it goes from the most southerly square here, through the center here, and down to the bottom, positioning the center of the egg in the same way that the table stone is positioned. See, it's positioned 3 to 2 relationship, a 3 to 2 relationship, the center here. Now, that gives the diagonal of that double square here. And Professor Thom showed that the radius of his circle was 17 rods. So that diagonal should be 17 rods long. And that's very interesting to see that 17 rods is 17 times 2.5 megalithic yards, which is 42.5 megalithic yards. And if I divide 42.5 megalithic yards by root 5, which will give me the side length of the square, because root 5 is the length of the diagonal, I get 19.006 megalithic yards, so it's exactly equivalent to 19 megalithic yards. So you can see that this same structure was used in the alignments and in the egg. Just one or two other interesting facts. From the center of this square, if I just take in exactly the limits of the egg, I have a perfect square. of 105 megalithic yards. And if I take in just the stones of the egg itself, I get an 18 to 19 ratio, which is a very important ratio also in sacred geometry and is used a lot in Egypt. Now, one final thing about this egg, I mean, we may think we've said everything there is to be said about the egg, but there's something very interesting still to be said about this egg shape. As you can see now, these are the 2, 3, 4, 5 triangles that orientated towards the north. And the side length, as I pointed out, of the long side of the 3, 4, 5, the 5 side is given as 25 megalithic rods. Now, a little more geometry here. If I've reconstructed these 2, 3, 4, 5 triangles back to back. And what I'm going to find out is what angle is missing here to make a right angle. So to do that, I'm going to draw another triangle here. 36 plus 36 plus 16.26 equals 90 degrees. So this angle here is 16.26. Now that is the exact angle of another Pythagorean triangle called the 7-24-25 triangle. And what's incredible here, you see, is that the 25 side is on the side of the triangle which measures 25 megalithic rods. So we have here, in fact, a numerical and metrological coincidence which is really quite astounding and which shows quite clearly that the basis of the whole structure must have been this 7-24-25 triangle. And it's particularly interesting to note that the corner of it is exactly in the axis of the last row of the alignments, row 11. I thought I'd show you this, a Sumerian clay tablet dating from the 3rd millennium, where we have the relationship between the 3-4-5 triangle, 2 back-to-back 3-4-5 triangles in a circle. And by putting a 7-24-25 ratio triangle here, that positions the center of the circle. So we see how the Sumerians had also shown this relationship between the 2 back-to-back 3-4-5 triangles, the 7-24-25 and the circle. That's some interesting information, very simply engraved on a piece of clay. Right. Now we're going to change and go to the other end of this part of the alignments, which are the Menec East alignments. Now, Professor Thom, I think, here made a mistake. I mean, he did a lot of very, very good and interesting things, but I think here he made a mistake. He was convinced that this end of the alignments was a kind of continuation of this, and there was this sort of just changed angle slightly. I think he made a mistake there. I think he was drawn into a mistake by stones which have been added. Anyway, we're going to zoom in on that part. This is the part of the Menec East. And what I'm going to do is show you how the stones go off. You can see how the rows go off. They're not aiming at this part at all, and they're certainly not in the axis of these stones here. You can see it quite clearly on this aerial photograph. The southern lines, in fact, converge to a point, and the eastern part of the lines come down in this direction. So there is no sort of simple continuity between the east and the west side of alignments. It's more complicated than that. But what I noticed is that, in fact, if you take the angle of the eastern alignment and project it, the first row of the eastern alignment and project it, you come right to the beginning of the 11th row on the western end, which gives you this diagram. Here's the eastern end. Here's the 11th row on the western end. And if you look at those distances which come straight off the satellite program, it's a 1-to-2 relationship, 430.93, 430 meters, 860 meters. So you've got an exact 1-to-2 relationship. And this happens to correspond to the angle of the lines at the eastern end. Here you go. You can see this is a standing stone, Le Crifol Menhir, which is the only remaining standing stone of a whole number of stones which were destroyed in 1905 by people who were building their houses with them. It was very common practice in those times. And if we look here, at this end, you can see 3 stones here which are aligned along that east-west line, and which clearly show that there's an east-west alignment there. And Professor Thom tried to fit those, as we'll see on his plan, on a line going down this way, which isn't going to happen. Here they are, look. He tried to fit them on that line. Now, his first 2 lines here, as far as I'm concerned, just don't exist. If you look at lines 1 and 2, there are in fact no stones on it, just this one, and that's one of the 3 east-west stones. So I'm going to get rid of them, because I don't think they've ever existed. And we're going to start from this row here. And then again, if I add the first 4 rows together, I get 27. And if I add the next 3 rows together, I get 27 again. So we see the same principle of the distance. The sum of the distance between the first 4 rows is equal to the sum of the distance between the next 3 rows. And that's going to enable us to discover the geometry behind it. Now, in Professor Thom's survey, the angle he gave for row 9 was 26.56 degrees, which is the exact angle of a double square. So I started by tracing this angle. There's a big hole here in the ground, and these alignments go off into that hole. But if you take the beginning of the row, it's quite clearly going on that angle. So I started from there, and I thought that if this is one of the stones in the cromlech. There's a cromlech here as well, which has these 3 stones here and this bit. I've put rings round the stones, which apparently are in row 3, according to Professor Thom. Now, if I take this line here and I put it there, you can quite clearly see it's exactly the same angle. There's no difference in angle between row 9, this row here, and this row here. And if I then extend that row, then I come to this stone. And we'll see that the same thing's true of this stone and this line, and this stone and this line. So in fact, we see that there's a precise angle of a double square. And that enables us to see that the organization of the Menec east alignments was the double square system. You can see how the lines go down like that. Now, what I've pointed out here, and I probably make some enemies saying this, but I'm quite convinced that the meter length was used at this period. It's a much older measurement than is accepted. I believe Napoleon, in fact, made it a popular measurement to sort of, how can we say that? He did it to kind of, I think it was the most secret measurement that was known to the cathedral builders and others, and by making it popular and well known, he was implanting the Republic and the idea of free knowledge for everybody, etc., and getting rid of secret societies and all that sort of stuff. But the meter length, I believe, goes right back a very long way. And if we look at the size of these squares, you'll see why shortly. I'll give you fairly conclusive proof of what I'm saying. But we'll see why here. If you take the diagonal of that 27 meters, and you put it on the side of the square, you get 10 meters, 10.01, or the big red square is 25.025. So the organization here could possibly be seen also in the meter length. Now, to get back to this geometry I showed you earlier with the triple square with its diagonal and then the 7-fold square placed on it to give the diagonal of the double square, look what happens when you superpose the Menec alignments on that scheme. In fact, what you see quite clearly is these lines go down the diagonal of the septuple square, whereas these lines go along the side of the septuple square. So the structure we saw at the beginning here, using the septuple square and the double square, is in fact used on a massive scale. And what's important to realize is that this is perfectly positioned with respect to north. So we're talking about a perfect positioning to 1/100th of a degree with respect to geographic north. Of course, we have absolutely no idea how anybody could have done something like that in 4500 BC. Well, we might have some ideas. Anyway, so here's the East Menec cromlech. I've taken Professor Thom's tracing off it because I think it's too approximate, and I think it was done in haste on this particular site. So I've taken his lines off to be able to show now the geometry I think was used there. So if we take the cromlech and the northern part of the cromlech, we have a circle of stones, which we can see, in fact, has this 20-meter radius, or the diagonal, remember, was 27 megalithic yards, 20-meter radius. And you can see how that perfectly goes through the stones of the cromlech. Of course, if the radius is 2 squares, then the diameter is 4 squares. And again, we position this double square. Now, if I, from the junction point of the double square with the circle, I then draw a diagonal, and I put a square here, right? From the corners here of that square, I can then draw 2 circles. One goes through the 3 stones remaining in the cromlech, and the other one positions the exact beginning of the lines here. Now, that gives us an axis. In fact, this axis is exactly the same as the one Professor Thom found. Just his geometry is not the same, but the axis he gave to his egg is the same. So this axis, it was interested, for a long time I was wondering what on earth that was, what this angle was, because it just doesn't seem to fit with anything. Until I discovered that if I put my double square here in the circle, and I draw the east-west line, this axis, in fact, bisects the large angle of the double square. And we can show this if I put 2 squares here. You can see how the axis bisects that, right? So in fact, the axis of this stone cromlech, or circle, or stone enclosure, is exactly half the greater angle of the double square triangle form. Now, this led me to a very interesting discovery, because if you work out that angle, which you can do by trigonometry, tan of -2, the total angle is 63.4349 degrees. If you divide that by 2 to get the angle with respect to the east-west line, you get half of that, 31.7174. Now, if you take the tangent of that, it's 0.618034, which is phi, 1 over phi, exactly. Now, I do think that, nobody knows about that. I don't think that anybody has shown a geometrical way of finding phi, in fact. And it's not approximate, it's precise. If you do your trigonometry in Excel and open up your columns to 50 decimal places, you get phi exactly to 50 decimal places. It's an exact relationship. And this seems to have been clearly pointed out here through the geometry used by these people all those years ago. That comes down geometrically to this. This is how you get the phi relationship from a double square. If you take the side length and bring it down here, then you take this length and bring it up there, then you've got the phi relationship AB to BC and AC. But if you half this angle, then ED to DC has the phi relationship as well. So that's the final result you get geometrically. And in fact, the whole thing fits into a square, which is 100 meters side length. Point E is the last stone in that... point E is that stone. It's one of the stones in the cromlech, the one which was the extension of the first line. Okay? Point E. That's very important, because we're now going to go and see another monument, which is the Tumulus Saint-Michel. This is 67,000 tons of stone and sea slime or mud, which have been used to build. That's an artificial hill, right? The chapel is a recent attachment. this is the thing seen from the air. Here again, for many years, I was wondering why this thing was orientated like that until the triple square thing appeared. And then I realized that the orientation of this tumulus is along the diagonal of a triple square. Now, as I'd already discovered that its shape was a double square, I realized that they'd placed a double square on the diagonal of a triple square. And then I started trembling from head to foot when I realized that if you add those two measurements, you get 45 degrees, which is the diagonal of a square. So that led me to a geometrical theory which I call 3 + 2 = 1, which is if you add a double square to a triple square, you get the square along the diagonals. Okay? Now what's quite astounding is that the path which goes up to the summit actually runs along the diagonal of the double square. Now, that's the plan. I managed to get hold of a detailed plan of the thing. It's interesting to point out that the dolmen which was found in it is a north-south orientated dolmen corridor, and it runs straight down the side of the square. And the central chambers are in the central part. Now, you can also, the width of the whole thing is 7 squares wide. The black square is 5 units, the triple square is 6 units, and the whole thing is 7 units. So the septuple square also fits into this thing. Now, around the tumulus, there are stones like this. I think that large parts of them are still under the ground. It's like round New Grange. Around New Grange you have stones, a stone circle around New Grange. And around this monument there are remains of stones. I've put them all in yellow circles. And you can see how they fit along the edges of this double square. And you can see how they position lines. This central point makes a point T here, which is then shown on the north-south by this stone. There's a stone here and a stone here which aim down to that point. From this point up to the corner of the square goes through another stone here. So the geometry seems to have been clearly placed. But what's very interesting is to discover that point T here is perfect south with respect to point E that I showed you earlier in the cromlech. So if you look at the organization of that, here's the tumulus Saint Michel at the bottom with that organization I've just done here. This is the cromlech, and they're in fact the same size. That's a 100-meter black square, right? And there are 9 of them. So that gives you 900 meters from the top of the cromlech to the bottom of the tumulus. And as you can see here, you've got 900 meters from that line to this line, 450 here. From here to the Kermario dolmen here, you've got another 450 meters. You've got 900 here. So in fact, you've got a double square there, a double square here, and a double square there, all exactly the same size. And the measurements here come off the satellite program, and you can see the diagonal 1007, 1007, 1007. The diagonal then proves the exact relationship. So you can see that there was an enormous structure going on in the landscape here, where this geometry, which we saw on a small scale here, was then developed on a much bigger scale in the whole of the Carnac landscape using tumulus, cromlech, the alignments. Now what this led me to discover, if I've got a double square here and a square here, that makes the top part a triple square. And if I take the beginning of the last line, line 11, and I continue it, I come to Kermario, which is, there it is, there's Kermario. And the other corner, there's the dolmen. This is the Kermario dolmen. Now, and that's the Crefol menhir in the other corner. We'll see a photo of that. There's the menhir. And you can see the tumulus Saint Michel from there, and you can see the beginning of the alignments from there. This is to show that there was visibility quite clearly to structure this thing before the trees grew and houses were built. And so if I now look at the relationship between the beginning of Le Menec West and Kermario, in fact, what I discovered, and which nobody has ever seen before, and which I didn't see for over 20 years studying these things, I didn't even see this, is that the beginning of these alignments are in fact perfectly aligned on these ones. So if I zoom in on the beginning of the alignments, here's the lines, and if I zoom on the Kermario part, here's the lines, and you can see how the stones are in fact perfectly aligned along the lines coming from the Menec. Now, because in the middle lines fork off, nobody's thought that they could have gone further onto the next part. So we see how this geometry links up this whole distance here, which is about 1,400 meters. Yeah. Now, what's interesting also to point out is that each line continues for a certain distance, and then the lines change direction. But here at the dolmen, the line that comes to the dolmen, then changes immediately. You can see the stones coming up here. This lower line, the most southerly line, has a totally different direction. So here's how it was traced using a 3-4-5 triangle. I call this joining the dots. Join the first dot to the second dot, the third dot to the second dot, the fourth dot, the third dot, etc. And that gives you the angle of the triple square from one end to the other. And this also points out why the first stones of row 6 go on the diagonal down that double square there. Now, just as far as measurement is concerned, the size of these monuments give measurement to the whole system. But this septuple square, which was the size of the monument, if I pull it over here, and then along that diagonal, I draw a septuple square, the size of the diagonal of this one, I then get the exact positioning of my septuple square along the Menec alignment, which is, in numerical terms, the small square here is 19 meters, which gives a 7-fold length of 133. Its diagonal is 134.35, and if I multiply that by 7, by root 50, I get the length of that diagonal, which is actually 950 meters. So I'm going quite fast here. I have to. Now, Kermario West and the summer solstice. Here's another view of the Kermario lines. And as we'll see, the beginning is in one direction, then they change direction. This is a very important point. That's winter solstice sunset, as we saw, and that's summer solstice sunrise. Now, here's the dolmen, and at this end of the alignments, there's a much larger standing stone. It's the highest standing stone in the whole of this part of the alignment. It's called Lemanio 2. It's about 3 meters 50 high. And it clearly stands out. It's on a hill. There's been a little hill built at Tertre, an earth mound has been built, and the standing stone has been put on it, and it's much higher than all the rest around it. Now, if you go from that stone precisely down to the dolmen, the angle here, this is Google Earth, the angle is 53.13 from the north. If you take that from 90, that gives you 36.87. It's the exact angle of a 3-4-5 triangle to 1/100th of a degree precision. Right. Now, the distance you'll see here is 1036.8 meters. That's the distance from the dolmen here to the tip of this stone. I've checked that using a GPS system which is precise to 1 centimeter. So that's the exact distance. 1036.8 meters, and that's exactly 500 megalithic rods. And this is the 5 side of a 3-4-5 triangle. Get me? So this triangle, in fact, going from the dolmen to this high stone here, is in fact a 3-4-5 triangle. There's the zoom on. You can see how it goes from the dolmen here right along that line. And then when you get to the end, there are 3 stones under here which show the angle, and there's that big stone. So looking at the beginning of the Kermario alignments, we'll see that there are different sections because the Kermario alignments slowly change direction to go from the triple square angle to the 3-4-5 triangle angle. So the most southerly line changes immediately, and then the other lines are going to change sort of gradually. So the first part here, you can see they're all aligned along the triple square, and this line comes straight from the Menec lines, the continuation of the other part. The next section in yellow, the lines take on the angle of the double square. See that? And then the final orientation, which is here, which is the blue angle, is the 3-4-5 triangle angle. Here's the same thing on a plan. This is Professor Thom's plan. You can see clearly how the rows change. And I'd like to point out two particular stones. Again, there's the table stone here. The point T is the table stone. And there's another stone here called the index stone, which is a sort of pointy shaped stone, and it's perpendicular to the alignments, and it's positioned between two rows. As you can see, it's in between two rows. There's a picture of it. It's about 3 meters high. It's a good stone, and as it's got a very pointed top, it's good for aiming at. And that's the table stone at Kermario. Now, here's a photo of the alignments. You can see how they're changing direction. But you can also see the line from the table stone which goes straight through the tip of the index stone and is taken on in part here by a part of the alignment. If we go further along these alignments, we then come to the next slope, which is the 3x2 slope, as you can see. 3 squares along, 2 squares up. We go straight along that line there. And this axis will continue to the end of the alignments. There we go, right up to that Manio-2, the big Manio-2 menhir. So what exactly is going on? The 3-4-5 triangle angle meets up with the 2-3 slope in that standing stone. Oh, here's a good view of it. Now look, right in the distance here, you can see the Manio-2 standing stone, and you can see how that alignment points straight to it. Now, from the tip of that Manio stone to the center of the table stone here is exactly 1,000 meters. There's the line. That's the index stone here. Goes through the table stone, through the index stone. And that's the tip of the stone. That's exactly 1,000 meters. And that's enabled me to draw this plan, which is a kind of scheme, a diagram, which shows how the 3-4-5 triangle goes up to the Manio-2 menhir on a 9, 12, 15, 500 megalithic rods, 300 megalithic rods, 400 megalithic rods. And from the table stone, you've got the meter length on a 2-3 slope, which 2-3 is 8 by 12. Got me? So there's one added square to go to 9 by 12 and get the 3-4-5 triangle. As far as that distance of 1036.8 meters is concerned, it's 500 megalithic rods, but 10368 is what's called a canonical number. It's 12 times 12 times 12 times 6, which is not a sort of, hazardous number. It's a special number. And the fact that this special canonical number has an exact relationship with 500 megalithic rods is a very interesting point. Now, what I want to point out is that this measurement, here it's 500 megalithic rods, but it's been used in several megalithic sites to great precision. Let's look at the Ring of Brodgar, you may know, in Orkney. This has a diameter of 103.6 meters, 50 megalithic rods. So if you trace the circle, going through the squares. Next site here is the Great Circle around Newgrange. There's the monument, and here the stone circle around it. Again, 103.6 meters. If we go to Avebury, there are 2 inner circles at Avebury. Here's the first one. Here's the next one. 103.6 meters. So this measurement of 50 megalithic rods as the radius of a circle, as the diameter of a circle, seems clearly to have been used in the British Isles and Ireland. And it was used very precisely on a 500 megalithic rod 345 triangle in Carnac a few thousand years earlier. Another very interesting point I don't have time to go into, I showed how the Menec alignments are linked to the Kermario alignments, but the Kermario alignments are then linked to the next section, which is called the Kermario alignments. There's a north-south line here, there's a square cromlech, and this line goes straight through the corner. That's the angle of a 345 triangle. And the distance to the east-west line, which is the axis of those alignments, is 1,680 meters, which we'll see later. So to summarize these three sections of the alignments, the first part, Le Menec, from the beginning of Le Menec to the Kermario dolmen, the angle, it's a triple square, and the alignments go along the diagonal of the triple square with a special thing here, as we saw. If I then take the Kermario section, this is a 345 angle, and it goes right up to the Kerliscon alignments. And the Kerliscon alignments are then east-west. And this angle doubles. So I've got 18.345 here and 36.87 degrees here. So the alignments then double. And what's interesting again is that the distance here, if I take this triple square and I put it here, it's the exact same distance of the four squares that give the length of the Kermario section. So we have the same 3 square to 4 square relationship on the large scale that we had on the very small scale at the beginning of the alignments. Now, Newgrange. I've got 1 minute left. Sorry. I pressed on the wrong button. Newgrange, Knowth and Dowth. Now, some of you may know that it's been pointed out that if you're sitting on Newgrange summit, when there's the minor moon sunset, the minor moon sets over Knowth. Now, that angle, there's a sort of a line as well in Knowth here which gives that angle. And that angle you can see here is 304.69 degrees. And the length here I've put in feet is 4,320 feet. Now, what's that angle? What is it? If you take, can you see that? If you take 3049.6 and you take 270 from it, because you're starting from the north, so if you just want this angle here, you have to take 270 off, it gives you 34.69, and that is 26.565 plus 18.13. It's a double square plus a septuple square, which enables you to do this diagram. You've got a septuple square here, 2 by 14, and look at this one. There's another monument here, which is the exact size of the square as these are, right? And it's right at the center of the base. So this angle is the exact angle. A double square has been tilted along the diagonal of a septuple square. Okay, and the mauve line, which goes from the center to this side of the square, gives you the 345 triangle. But that's something else. And I then went on, I'm doing this very, very quickly, but I then went on to show that, in fact, the distance between Newgrange to the other side of Dowth here, 6,480 feet, is 1.5 times that distance. And the angle here is 31.717. It's the angle 1 to phi, which we found in the Carnac cromlech. And the distance on the east-west line here is 1,680 meters, which is the distance I just showed you as the length of the 345 triangle. And another thing, very interesting thing that comes out of this is that the distance between this point here at Knowth and Dowth is 2777.77 meters, which is in fact exactly 1.5 nautical miles, or 1/2400th of the Earth's circumference, which is a rather strange, very interesting fact. And these distances are exact, they're calculated. Yeah, there's no sort of moving things to make it fit. Now, Longmeg and Castlereagh, two very well-known monuments in the north of England. I got interested in Longmeg because its latitude means that you get summer solstice and sunsets at 45 degrees with respect to an east-west line. So in other words, the square would be a really interesting shape to be used at Longmeg for tracing the solstice angles. Now, what I discovered is that you'll see that this is done very precisely, but to show you the line, I've had to zoom out. Longmeg is here, just northeast of Penrith. Castlereagh is here, just to the east of Keswick. And the angle between those is 243.44 degrees, which is, if you take it from the east-west line, 26.56 degrees. It's the exact angle of a double square. Now, if you look closely at this section here, you'll see that that line going from Longmeg down to Castlereagh goes exactly down the centre of a valley. You can see the hills on this side and this side. And there's a valley goes through there. That's where the road goes. And that's this angle. In fact, you can see how the valley is exactly on the angle of that double square. Now that opens up a whole chapter that I can't go into, which is the relationship between these geometrical forms and the landscape. And I do believe that these people actually used the landscape and earth energies, because they were orientated in particular directions, and that seemed to have some kind of sacred influence. Now, if I zoom in, so you can see that's the double square. If I zoom in on Longmeg, that's where it hits Longmeg. You can see 243.44 degrees. And if I zoom in on Castlereagh, that's where it hits Castlereagh. So you can see, I mean, we're talking about 31.12 kilometres between the two sites as the crow flies. And that kind of precision is absolutely unbelievable. Now, another interesting fact is just near Longmeg is a site called Little Meg. Here's a photograph of the engraving on one of the stones. Here's Little Meg. If you go from Little Meg to Longmeg, 243.44, it's again the double square. And look where it goes through Longmeg. It goes through this stone and then down to this entrance shape here, coming from Little Meg. You quite clearly see there's a double square relationship between these two monuments, which then extends over to Castlereagh. Now, also from Longmeg, you can see Helvellyn, which is the third highest summit in the British Isles. And Helvellyn happens to be at exactly 225 degrees, which is exactly 45 degrees south of the west line. So if you're looking toward the west and you come 45 degrees down, you see the summit of Helvellyn on a clear day. And that is where the sun sets on winter solstice seen from Longmeg. So Helvellyn was used as a sighting point to get an exact square, apparently. And its name, Hel, like Helios, the heel stone in Stonehenge, Helios, the sun, could clearly imply that this is the spot where the sun goes down. I've shown the pattern here. This is Longmeg here. This is the summit of Helvellyn. So you can see there's visibility from that spot to that spot. There you go. And that's the line through Longmeg. See 225 degrees through Longmeg. It goes right through that same stone and through Longmeg down to Helvellyn. There you go, down to Helvellyn. There's the lake, and we're exactly down the middle of that valley. You see how the valley is orientated at 45 degrees, and how the sun sets down into Helvellyn on that 45-degree angle. Just to finish, a little trip to Denmark. I'd like to thank Richard Heath for telling me about this site. This site is in Langdisse in Denmark, and what I discovered was that the angle of the side of this is a sort of stone enclosure, and the side angle here, as you can see, 53.13 degrees again, is the exact angle of a 3-4-5 triangle. Now, this is at the same latitude as Long Meg. We're in Denmark. We're at the same latitude of Long Meg. Now, this is the 3, 4, 5 triangle angle. If I then put a septuple square in there, you see how the length of the monument is 7 times its width. Okay? So the monument, you can see, is a septuple square. And if I trace the diagonal of that septuple square, I get 18.13 added onto my 3, 4, 5 triangle, gives me exactly 45 degrees. So if you go to Langdisse in Denmark and you stand in this corner, you'll get summer solstice sunrise along the diagonal of that septuple square, which is the same phenomena you can see in Brittany at summer solstice, where in the quadrilateral, which is a 3, 4, 5 relationship, you get summer solstice sunrise along the diagonal. That's incredible how this geometry has been used at a given latitude. It's quite beautiful, I think. And I'll stop there. 1 hour and 10 minutes.